Hello, everyone. Thank you for joining. Hope you're having a great experience attending Bill from the comforts of your home. My name is Asrar, and I'm a Senior Business Program Manager for Microsoft for Startups team. Today, I'm joined by Jeff Ma, General Manager of Microsoft for Startups Business, as well as Roger Noble, Founder and CEO of Sagami, and Aggie Gurkowska, Marketing Manager at Sagami. For the next 30 minutes, or so, we're going to explore how startups are turning the avalanche of medical data produced by the pandemic into useful, actionable information. At this time, I wanted to remind everyone of our code of conduct. At Microsoft, we seek to create a respectful, friendly, fun, and inclusive experience for all of our participants. We encourage everyone to assist us in creating a welcoming and safe environment for all of our attendees. Before I hand it over to Jeff and Sagami, I wanted to quickly explain Microsoft for Startups program for our attendees. Microsoft for Startups is an equity-free program available in 140 countries around the world. It's designed for C to Series C, B2B startups. We have two pillars designed to help companies quickly scale. The first pillar is about access to technology so startups can build their product. The program offers up to 120,000 United States dollars of free Azure Cloud, powerful developer tools including Visual Studio and GitHub Enterprise, and technology that startups need to run their business like Office 365 and Microsoft Power Platform. We also offer enterprise-level technical support and architectural design sessions along with one-on-one consultations with our engineering teams. The second pillar is really centered around business acceleration. How can we connect innovative startups with Fortune 100, 500, 1,000 customers? We do this with a streamlined path to partnership, which includes a startup engagement manager who's dedicated to helping startups navigate their partnership with Microsoft, assistance in getting your startup solution listed in the commercial marketplace so it's available to customers all around the world. And most importantly, connection to Microsoft sellers who are compensated to sell your startup solution into their enterprise customers. To learn more, please go to startups.microsoft.com. Now, before I introduce Jeff, a little bit about his background. Jeff recently took the helm of the Microsoft for Startups business. Along with founding and exiting 4 successful startups, Jeff and his friends from MIT were the inspiration for the movie 21, where they use probability to take Vegas casinos for millions. Beyond his work as a founder, Jeff Ma is a best-selling author and speaker who has helped the 49ers, Portland Trail Blazers, ESPN, and Major League Baseball make better decisions using data. And Jeff is joined by the team from Sagami. Sagami has developed a solution for looking at large collection of images to spot patterns and outliers in chest x-rays of COVID patients using machine learning and artificial intelligence. And with that, I'll pass it over to Jeff. Thank you.
Thanks, Azar, and thanks to the Sagami family for joining me. This is a topic that's sort of near and dear to my heart, and as I thought about all the great things we could talk about at Build, this seemed like such a great one and such a relevant one, given the real challenge we're facing with the pandemic. I think that as someone who's sort of passionate about data and analytics and sort of has made a name for myself in that space, when the pandemic hit, I became fascinated, almost obsessed with the idea that this was going to be like the Super Bowl for data analytics people, as you know, everyone was focused on the different models that were out there that were being used to sort of inform policy as it pertains to the pandemic. I became really concerned that this was going to be a time where the modeling community and the analytics community was going to be challenged by the fact that the data that was available to them was not particularly good and was biased and was false and was generally just not the best data to build models, because obviously when you build a model, you're at the mercy of the data that goes into that model. So as I learned about Sagami and what they were doing with Microsoft for Startups and what they were doing with Azure, I became really interested in sort of how the solutions that they were doing could really help inform better COVID, research or COVID policy. So we'll turn it over now to the team to tell us a little bit about sort of what they've been doing in this world.
Thanks, Jeff. As mentioned, I'm Roger, and I'm joined with Agata, and we really just wanted to give you a bit of an overview of some of the work that we've been doing to directly help with the COVID-19 effort. But first is just a quick overview of who we are and what Sagami is. We are a data visualization platform that really allows anyone to easily find patterns, outliers and trends in large amounts of images and other visual or unstructured data. And to do this, we use a combination of unsupervised machine learning to extract features and analyze data, as well as using a highly dynamic visualization to really allow you, the user, to gain real insight and value from these kinds of data sets that are traditionally quite difficult to work with. And so with that, I'd just like to hand over to Agata just to give you a little bit more detail on how we've been using Sagami to help fight COVID-19.
Thank you, Roger. So in a nutshell, Sagami is working on a remote collaboration platform to bring healthcare practitioners and researchers together to support the detection of COVID-19. The tool will be based on our existing data visualization platform, Sagami, in addition to our proof of concept machine learning model that has learned to identify COVID-19. It does this by analyzing lung X-rays and currently has an accuracy rate of about 70%. As Jeff already pointed out in the beginning, the success in machine learning model heavily depends on the data that's ingested into it. And machine learning model can pick up on very abstract features, more complex than a human eye can possibly notice, and identify specific patterns that correspond to certain diseases like coronavirus. Because we sourced our data from publicly available sources, the images that we received unfortunately contained various inconsistencies, including markings, lines, or various other things that can cause a machine learning model to make incorrect assumptions when making classification decision. With Sagami, you can visualize thousands of images in one single view, in addition to metadata that corresponds to that image. And you can apply various techniques, including automated clustering. And in that way, you can very easily and quickly remove all these outliers from your data and feed good quality data into your model. And then the next step, after you train your model, you need to validate your results. And again, Roger will talk about it in a bit more detail, that with Sagami, you can sort of explore visually and understand why the machine learning model has made certain decision, and understand maybe there's a bias in the model, and quickly go back and train your model to correct these issues. And finally, machine learning model needs huge quantities of data in order to be accurate and robust. So we are currently in conversation with National Health Service here in the UK to source additional images and improve on our model. Also, we have been lucky to be based here in Oxford, and we already gained interest from Oxford University researchers, as well as media across the world, including Financial Times, Daily Mail, and China Daily. And we're hoping to attract people to work and collaborate with us together on this. And now I'd like to pass you back to Roger, who is going to show Sagami live.
Thanks, Aggie. So yeah, I wanted to give you a little bit of an overview of Sagami and exactly how it works, to really highlight how it's useful in looking at these sort of really large and complex data sets. And really the challenge for us was to be able to build a machine learning model as a proof of concept to really see if we could reliably identify chest x-rays with COVID-19 versus other types of issues like pneumonia and other types of things. And so Sagami is really useful. As mentioned, we can display tens of thousands of images on a single screen, and you can see here we have a collection of example chest X-rays, and in the main viewer area, it's really easy to zoom in and really rapidly get a good bird's eye view of your data set, but then also be able to zoom in to the detail and see all the metadata that we have that's associated with this individual image. So it allows you to look at a large amount of images at once, but then zoom into the detail. Not only that, we have ways of filtering and grouping and sorting those images, so you can really start to spot where you might have outliers or other types of data that gets in and can potentially bias your model or make your model have underlying issues that are difficult to identify. In general, machine learning models are a little bit tricky to build because they often tend to cheat. They like to find the shortest path to a solution, and so they highlight or focus in on areas that maybe you don't want them to. But using the filter panel, we can get a good understanding of our data set. So, for example, I've just clicked the age here, and we can use that as a filter. So we could, as a simple example, just filter down onto those older X-rays where we already know that older patients are much more susceptible to COVID. Not only that, we can filter on various conditions. For example, we might just want to focus on just those X-rays that have COVID, so then we can see, does this data look good, and is it a good enough quality to start feeding into a model? As you can see, the view is sort of dynamically shifting and changing as I'm filtering here, and we have a few different ways that we can actually display and view these images. Another one that's particularly useful is this graph view. So what you're seeing here is a distribution of all those images across one of our columns in the data set. In this case, it's age. And again, you can already see there's a bit of a skew in the data set towards those older patients. But within this view, we can drill in and look at each one in more detail and see if there are any particular issues that might be highlighted. A simple example of things that you might be looking for is, for example, this image here is actually of a side or a lateral view, and that's not the kind of thing that we want to be using in our training data set, because we're only looking for images like the one next to it, which show both sides of the lungs there. So we can quickly identify these types of inconsistencies in our data set and tag and label and exclude them. One of the really useful things that we can also do with Sagami is use unsupervised machine learning to cluster the images and identify patterns and within those. And again, this is really useful, as mentioned, with those lateral images, where a lot of them have clustered together here because they're all quite similar in their orientation. And so Sagami makes it very easy to then not only spot and group all those together, but then I can just quickly lasso around all of those and tag them to be excluded from the data set. One of the other things with looking at radiology type data sets in particular is there's lots of variation and within the images themselves, but also in the types of patient that we're dealing with, and things like the size of the patient, their weight, their age, and also if any kind of contrasting agents or anything else have been used that can sort of typically bias the data set. And again, because machine learning models like to cheat, they might kind of overfit to identify these types of patterns when actually in the real world, they might be being used against completely different data sets. And so that's where Sagami, again, is quite useful. Already this clustering is sort of highlighting that there's a sort of a darker region where there's a higher sort of darker contrast in these images. And in this case, this is because a lot of these images are actually from a pediatric hospital. So they represent a lot of children. Again, as we know, that may not be something that we're interested in training, so we can quickly exclude that from the data set. One of the other really useful things to do and to really make sure that we're developing these models and putting them in the hands of clinicians is that we need to make sure that they are that they're robust, but also well validated, and that, out in the real world, we're not, prescribing people, that have diseases that they don't have, or saying that they don't have something that they may have. And really the only way to do that is to validate your models against non-training data, but also to really, for regulators, to have a really good understanding and insight into the data that was used to train the model. And that's something that Sagami allows you to really easily do. One of the neat things is we can overlay colours over these images, and the colours in this case represent the different conditions. So up the top here, we've got all the orange represent the COVID, all the green ones are healthy, and then on the red and the blue represent sort of viral and bacterial pneumonia. And already you can see that there's some confusion around those types of pneumonias, but in most cases there's quite a clear separation between the COVID and the healthy lungs. So these are just all little tools and techniques that you can use to really get a full and good understanding of your training data, and to produce the best models possible, but also to do it in the fastest way possible. So just in summary, we built a machine learning model for looking at X-rays, specifically to demonstrate that it is possible to use machine learning to differentiate between COVID-19 and normal healthy lungs. The model that we use has an accuracy rate of around 70%, so not amazing, but that really comes down to the amount of data that we had at hand. And really, to improve this model, we need a lot more data, a lot more examples, and a lot more diversity in our data set, so that our model is sort of less biased and more robust to seeing different types of images and imaging modalities. So that's it for us, and yeah, thanks.
Thank you so much, Jeff, Aggie, and Roger. And with that, we'll open it up for questions. So the first question that we have from the audience is, could you see Sagami being used in radiology departments around the world?
Yes, absolutely. Yeah, I think this one of the important things about using any kind of AI in a clinical setting is to be able to have the explainability aspect. So a clinician, a radiologist, is able to use AI, but then is also able to understand what this black box, this machine learning model is actually telling them. And by being able to use Sagami, they're able to see the images within context and sort of really understand what are those shortcuts that model's trying to make. What are those, how did the machine learning model come to the decision that it did, so that they can kind of diagnosis for the patient. And so clinicians really need to understand the inner workings of a model so that they can produce tailored and better outcomes for their patients.
Thank you, Roger. The second question actually that we have from the audience is regarding explainability and checking things like bias. Apart from visually checking, is it currently or in the near future on the roadmap to include things like interpret ML, fear learn, etc., to get metrics to steer on and mitigate?
It's something that we're actively exploring. One of the things that we're looking at that I wasn't able to demonstrate today is that we're creating and generating heat maps from our model to sort of highlight those areas that it's focusing on. And this sort of, again, helps with that explainability piece. It was something that was really valuable to do early on when we were training, because we actually found, because a lot of those COVID X-rays were from medical journals and research studies, they some of them, and you might have seen them in the demo, some of them had like little pointy arrows in them, and the pointy arrows were pointing to areas of interest, and the machine learning model was actually learning to identify, if you have an image with a little pointy arrow in it, that has COVID. And so not only was Sagami useful, but then having the heat map to sort of understand those areas where the model was focusing in on allowed us to quickly see, oh, okay, we need to exclude these little arrows, otherwise our model's going to go off the rails.
No, that's super helpful, Roger. Thank you for that. The other question that we have, can you explain a little bit about how do you spot outliers in using Sagami in all these chest x-rays?
I guess that's one of the neat and unique things about Sagami, in that while we do use some unsupervised machine learning to sort of do that clustering and looking at similarity, by presenting all of the images on the screen at once, actually a lot of the outlier detection is just done by our own brains. So by visualizing them, we're able just to identify those patterns, and really it's about keeping the human in the loop at the whole time, at every stage of the process in developing a machine learning model. So we can kind of use our own intuition and background to sort of spot where things might be going wrong or right.
And then that's super helpful. I think building on top of that, what data or image formats can you analyze using Sagami?
We work with a lot of the kind of the more regular standard formats that I'm sure everyone's aware of, JPEGs and PNGs, GIFs, those kinds of things. But we also work with imaging formats, which is a standard called DICOM. So we support DICOM images for the most part, which is a bit of a tricky thing to do, but we're sort of actively working to have as much and universal support for DICOM as possible. But it's a tricky one because DICOM as a format is sort of a wrapper, in that there's a standard headers and a wrapper around kind of like a blob that's in the middle, and the blob could be images or video or anything. But at the moment we have support for images, videos, and in multiple bit depths as well, and we're sort of actively making sure that we support all sorts of other different formats in that standard.
Thank you, Roger. And the audience here is actually really excited about Sagami and the images and the solution. So real quick question on that, is it possible to annotate images using Sagami?
We have basic annotation in that web sort of browser-based client that I was showing you before. So you're able to just do tagging. We have a companion tool called Amethyst that we're close to releasing, is in early access at the moment. And that allows you to create not only sort of bounding boxes around regions of interest, but also you can create sort of pixel perfect segmentation masks. And we have a few kind of neat computer vision type techniques to make generating those masks really quick and time efficient. So you can effectively draw a box around a region or an object of interest, and then we'll compute or work out very quickly the right mask, and then you can tweak it from there. But it's a companion tool in that it works very closely with the main Sagami client, so that we can synchronize images and data and the masks between Sagami client and Amethyst, so you can sort of collaborate around annotating images.
That's great. I think that our audience is already thinking of solutions and application of the Sagami solution, which is great. So could something like this possibly used for safety in a warehouse? So for example, spotting risks of falling stacks as an example, or possibly cracks in mine walls where some are benign and others have a risk associated with them?
I think so. I guess where we see ourselves sitting is that we are a tool that's part of a data scientist or a researcher's toolkit. And so we enable and allow people, developers and researchers to create machine learning models, but we ourselves don't usually in our day-to-day create our own machine learning models. So you could quite easily, use Sagami, pull in a bunch of images from a warehouse, annotate them, and then train a machine learning model, and then you could take that model and deploy it in a production environment so that you could detect that kind of thing. But we ultimately are trying to make sure and help people to create better and more robust machine learning models, so they don't kind of get into these types of issues where they become out of date or irrelevant over time.
That sounds great. Now, what ways can a beginner data scientist contribute to Sagami and contribute to helping with this pandemic that the whole world is going through right now?
Yeah, we're actively looking at ways to get more people on board and collaborate, and I, completely agree. I mean, this is a problem that can only be solved by everyone pitching in, which is sort of why, we wanted to throw our hat in and help out in whatever way we can. We have a grants program which you can get access on our website, so you can apply to get free access to Sagami. We're also the model that we trained. Our model on was based on a crowdsourced data set. And so if you have access to chest x-rays, feel free to contribute to that data set as well, which is something that there are many researchers working around the world based off that data set. But also just reach out and, more than happy to have a chat and see what we can do together.
Great. The next question that we have, now you're part of the Microsoft for Startups program and you're building on Azure, correct? What are some of the Azure services that Sagami is using currently for building this solution?
Currently, we are a big user of Azure Kubernetes service. So Sagami, as a sort of server-side component, is a series of containers that run multiple jobs for image processing and machine learning, and serving up web pages, that kind of thing. And then we use storage accounts to store our sort of pre-processed or intermediate blob files, as well as data files. And on our roadmap, we're looking then at actively using more and more of other services like cognitive services in particular to sort of leverage that and also make it a lot easier for people to start training their own machine learning models.
And then Sagami also has a solution on Azure Marketplace, right? So one of the things that we talked about in the introduction was, as part of Microsoft for Startups program, startups can also host their solution and publish their solution on Azure Marketplace, which is available for customers and users all over the world. Can you please shed a little bit of light on how Azure Marketplace has been helping you to grow and scale your business?
Might throw that one to Aggie.
Hi, yes, it's a great resource for people to be able to access Azure, and you can from there also access our free trial and try Sagami. So yeah, feel free to go and check it.
I think that's where, being part of the Microsoft for Startups program has been a huge advantage for us. I mean, it gives us access to a huge customer base, all of Microsoft's partners. So if anyone else is looking at using Microsoft for Startups, I definitely recommend it.
So would the best way for our attendees and customers and users all around the world, would the best possible way be going to Sagami website to download the solution and try the solution, or also go to Azure Marketplace and find Sagami solution and run the solution and run a free trial of the solution?
Yeah, you can do both, and it's easy to remember. Sagami means images reversed, so it's easy. Either go to our website, sagami.com, or go to Azure Marketplace and search for our solution there. And yeah, we're always here to help, and feel free to reach out to us.
I actually had not thought of Sagami as being images, so I'm just curious now myself. How did you come up with that name? Like, who came up with this idea of switching the characters in images?
It was just a long process of going through pages and pages of ideas. It was actually our other founder, Steve Taylor. He's a computational biologist at Oxford, and it was just a thing actually over a beer. He just said, "What about images backwards?"
That's great. Well, thank you so much, Roger, Aggie, and Jeff, for your time today. Really, really great to hear from you, and thank you for helping the whole world by having your solution out there for all the users to use. And again, as a reminder for everyone, if you want to try and use Sagami solution, please go to Sagami's website or search for Sagami on Azure Marketplace. With that, it's a wrap. Thank you, everyone, and enjoy Build.
Thanks for having us.
Thank you.
Thanks.